Mail time. Made with Pride in Malta by Luke. Man, these look amazing. Yeah, g'day and welcome back to this, my old lathe channel. Got a bit of turning work to do today, so I'm not working on the lathe, I'm working with the lathe. Now the 16-inch DoAll is a fantastic bandsaw. With both a constant velocity transmission plus a back gear, it gives you a really wide range of belt speeds. So you can cut everything from like wood right down to super hard metals and difficult to cut alloys. But I got this saw cheap because the gearbox was koozed. It released a Woodruff key, which got in between a gear set, knocking off one of the teeth. This task's been up here on the to-do list ever since I got the machine. By the way, I'm doing a Patreon live stream on the 8th of September, I think that's a Friday. Come and join me. Alright, let's take a quick look at the function of this gearbox. So this is the input shaft, driven by the electric motor through a variator. These gears are always in mesh, so the lathe shaft is always driven. Down here on the lathe shaft, there's an eccentric. It's normally keyed onto there. That cam drives the oil pump, squirting oil through the whole thing. This gear is also always in mesh. So the gears are always turning. This is our shifter here, and it selects between engaging this pawl, which is keyed onto the input shaft, and then drives a set of keys to the output shaft so that those two rotate 1 to 1. And of course, the gears are still turning, but there's no key on the shaft, so that's just rotating. In the back gear position, the pawl gets shifted across, disengaging the input shaft from the output shaft. So now the power's going in, transmitted down onto the lathe shaft, comes back up here, and the power's transmitted from this gear through the pawls here, and also onto the output shaft. But at I think a 7 to 1 reduction or something like that. The weakness of the system is that while the lathe shaft is supported by bearings at both ends, the input and output shaft each only have one bearing, and they support each other with an interstage bushing. This here. And that slogged out. And it's slogged out bad enough that the two Woodruff keys, which drive the selector dog, one of them got released. Looking closely, this is not the first time this has happened. I can see weld build-up. So what I think's happened is that this has failed before. Someone's gone on, welded it back up, remachined the Woodruff keys, and put in a new bearing, but then it's just slogged out again. DoAll still sells replacement parts, but their price on the shaft was about 4 times what I paid for the whole saw, and I couldn't afford it. And this is where Luke, the wonderfully generous machinist from Malta, comes in. He offered to turn up a replacement input shaft and cut the gears for me. I made up a drawing of the part as it came out of the machine, which has got a DP11 gear set on it. Luke got me to also measure the pitch distance between the shafts in the housing, and that's when Luke identified that it's got a profile shift. His suggestion was then to make a pair of matching Module 2 gears rather than trying to match the profile shift of the DP11 original gear. Given the fixed gear ratio of 11 to 46 and the fixed shaft spacing distance, Luke worked around with the helix angle of the Module 2 gears until he came up with a gear set that would fit into the existing box. To cut the helical gear teeth on his manual mill, Luke first had to go through his set of change wheels and bore out all of the centers to match his indexing head. It's pretty mesmerizing to watch mechanical gear cutting, especially helical gears like this. Thanks also for shooting all this footage, Luke. And right now, I'd like every single one of you to give a thank you comment in the comments section to Luke for going above and beyond to make these for me, but especially also to film them so you could see it as well. Please show him your support as well. Thanks. These gears are made out of 4340 steel. Especially the input shaft will have to be hardened because it runs in that interstage bearing. Mail time. Fantastic. Thanks very much, Luke. That's just brilliant. I can finally put the DoAll back together with a proper gearbox and finally be able to cut ferrous metals with low belt speed. That is absolutely brilliant, Luke, and beautiful workmanship. Thanks very much. I'm going to manufacture this shaft again from scratch, and although there is a pressure oil system through here, I've bought a slug of oil-tight bearing material, and I'll make the bore to match this for that new interstage bearing. Since I'll be manufacturing a complete new shaft, I can also increase the diameter of this feature, which is the shaft for the lower belt wheel, because I noticed that wheel's a bit slogged out, and rather than sleeving the wheel, I can just manufacture a slightly bigger shaft here. Right, that's roughly what I need. First off, I better chomp off a bit of my 6150 spring steel. So I need 141 millimeters. This is the first thing that I could probably cut with the bandsaw if I had a gearbox working. Right, I'll get this chopped down before my daughter comes over because she wants to watch the Formula One race in Holland with me. I think it's kind of funny. Last 20 years, my kids gave me hell for sitting watching motorsport every Sunday afternoon. And then Netflix brings out Drive to Survive and suddenly the two of them are the biggest Formula One fans you've ever seen. Now before I destroy my nice chunk of spring steel, I'll do a test thread on a piece of old, I guess this is just mild steel. I brought a new tool, one with the, was it DCMT or VCMT inserts, because it's easier for cutting like the relief grooves on the back of threads and stuff like that. And this one's got the 16mm tool holder, which is the size that's designed for this lathe. So now I just need to dial it in. Okay, so at the moment it's way below center height. That should be okay just to get me started. I can fine tune that later. It didn't work too badly. I need a chamfer on the front next. So the big question, how does it fit? That's too tight, needs to go in a bit more. I wonder how this nut got so chewed up. It'll work. It was recommended to me to do this setup with two chuck keys. Luckily I've got two. I've got a similar chuck for the bolly, one size smaller. This is the first time since reinstalling the saddle that I've offered this manual tailstock up, and I've just realized that this lever is going to hit on all this. Just drive the whole saddle back and see if I can mount it, but maybe I'm going to have to end up modifying this lever. The CNC pneumatic tailstock has this lever coming out forward. I could definitely bugger this up if I wasn't careful though. Still have to make the parts for this. The next question is whether I'm going to have enough stick out with the manual tailstock, because the CNC tailstock is longer across the neck here. Well, this will sure get easier once I put a handle on it. Well, plan A didn't work. That's full extension, and I'm not even in there yet. Best solution will be take off the tool changer and just use the rear mount tool block out the front to carry my tools. Have to dial everything back in again, but hey, got to do what you got to do. Well, that's full extension, and it looks like my roam centre is going to be too short. Luckily I've still got this cheap and nasty centre, and that is a bit longer. Yeah, that's going to work. I never really understood why they made these threading tools with this geometry. Cutting a thread on the end of the shaft must be one of the most common places to put a thread, right? And shafts are often long and need tailstock support. You would have thought the most common design would have a different geometry to allow better relief in this area so you don't hit your centre. Well, all those changes mean I've reset both of the tools I'm going to be using. I think I'll do another test piece on the other end of this bar just to get everything set back up again. Okay, I've come to the conclusion I really can't make this setup work. This needs to go into a diameter of about 13 millimeters, but then I'll be hitting. So to address that, I've just set up a high-speed steel 60-degree angle threading tool. This tool holder's also got an extended nose on it, so that also gets me in a bit closer. Wait a minute, that's got a right-hand grind on it, so that's the cutting edge. But this is a left-hand thread, so I need to regrind that top rake in the other direction, don't I? If I'd done it with the Clarkson, it would have been prettier, but hey, there's the top rake moved to the other side. Nice precise scrap. .36 to nearly 38.5. It's a huge taper on there, but I didn't program that. Nothing set here is a taper. 2mm depth of cut, 0.15 per rev, heading to -19, but I don't understand why that set a taper. But I'll start at 39 and just see what happens. Yep, that's cutting a massive taper, but I have no idea why. I'll stop that, shut that down and ask for help. Mail time. I got contacted by Dominic. I'll put a link in it to his channel below. A very generous Swiss gentleman. Oh, that's really nice. He sent me a bunch of milling cutters. Thanks very much, Dominic. That's awesome. Wonder how long it'll take me to kill all of these. Now, some of you might have thought that MTU was a massive German, I think, aerospace concern, but you're wrong. Whereas this box, I bought myself. One of the gentlemen on the German Zerspannungsbude forum, Jan, was selling off a bunch of offcuts, and I figured, hey, 10mm aluminium plate, you always need some of that. Also a couple of bits of, I think, 20 or 25mm plate, and I thought that'd be perfect for sort of a sacrificial tooling jig. So I got a couple of them. It's the next day, and I got a solution from the LinuxCNC forum why I was getting that taper. Spomco noticed the G64 just here. Looking back in the history of the commands that I typed in, you can see there's a G64P2. I did that by mistake because M64P2 changes the speed of the constant velocity transmission. whereas G64 is a blended motion command that allows LinuxCNC's trajectory planner to deviate from the toolpath and cut the corner. Now, why would you want to let the machine wander off its nominal toolpath? Well, glad you should ask. Let's say you're doing a nice curve here. There's my center line. G-code, unless these are actual circular toolpaths, you have to break this down into a bunch of straight sections. If you're using a full stop mode, G61, it would mean that the tool goes cut the path, stop, cut the path, stop, cut the path, stop, etc. And at each of these points, you'll get a nasty little line in your surface finish because the machine stopped. And this is where you use G64. LinuxCNC's got a look ahead function. I think I've got mine set to look even 20 blocks ahead. If we massively exaggerate that first angular change there, it's moving at a certain Z velocity and a certain X velocity on the first move. The second move is going to be a slightly greater Z velocity but a smaller X velocity. The machine's not capable of instantaneous acceleration, so you've got to give it a little bit of time to, in this case, slow down that X-axis to meet the new trajectory. That's what we're doing with the G64 tolerance. It's just giving it a little bit of allowance to cut the corner so it can keep its speed rate constantly across the metal, avoiding nasty rubs and defects in the surface, but you get a slight deviation from the toolpath. G64 needs a P value, which tells it how far away from the toolpath it's allowed to deviate. In my setup file, I allow 0.1 of a millimeter as my standard, but of course, when I typed in P2, I overrode that. Right, I'll need a steeper tool to get in that last bit. Alright, that feels good. Right, the next part of the shaft is this bore that felt a bit loose on the temporary shaft I made, so let's measure it up. I'll do a few measurements throughout the bore and just see how parallel it is. God, I'm getting measurements all over the place. This aluminium bore really isn't that accurate. Well, those measurements would indicate that the bore is kind of belled out down to this backside, up by about 5/100ths of a millimeter. I think I'll just rebore that on the mill to clean it up and then match the shaft. Right, well that's the shaft roughed in. It's all hot as, so I'll leave it overnight to cool down. Right, next day, it's cooled down overnight and I can do the final machining. This is going to have to be oversized to compensate for the slogged out bore of the main drive wheel. This is a bearing seat. So with a rotating shaft load, I'm going to want a K5 or K6 tolerance, which basically gives me tolerances of like 2 to 13 mu. Whereas this here has this gear rotating on it, so it's a sliding fit. This bore is also under nominal. It's not 35 millimeters, it's 34.9 something. Here I'm aiming for the same diameter as the previous shaft. Okay, the tool's measuring about 5 microns undersize on that cut. This is not that critical. I'll match the bore to it, but by dialing in this tool super precisely, hopefully I can then turn the bearing with no worries. Since the bearing's close into the chuck, I think I'll do this cut without tailstock support. They're only fine cuts. So my tolerance was +2 to +13 microns, so we're in. That shoulder needs cleaning up and a very slight undercut. Now this shoulder, right, final cut on diameter. This is zeroed on the old shaft, which I'm taking as my nominal. I've gone about 3 microns, 3-4 microns under. That's good. That's supposed to be a loose fit so that it rotates. Alright, anything else I still need to do with this in the lathe for this setup? I don't think so. There's no real chamfers on this. I just took off the sharp edge with a file. Time to flip it around. I think I've got that dialed in now. Right, finishing pass here. Right, that's another feature done. So next up, I need to do the bore for the intershaft plane bearing. Back gear plus variata gives amazing low end torque. I've got no tool holder to hold a boring bar on this tool post, so let's switch things back up again. Okay, it took me a while, but got that set up. So let's just do a test cut and see the diameter. As always, this has taken me much longer than expected. Right, well I still need to machine the various slots and stuff here, put an oil hole there and also into the input shaft, do some heat treatment. So I'm not going to get done today, but huge thank you to Luke. This has been fantastic, mate. And thank you all for watching. Tune in next week where I'll hopefully make some more progress.